And my registration number is 17BEE0186. Today I am going to talk about a very important topic regarding mathematics. It's called real world application of multivariable calculus. Basically, as the name suggests, we use this part of mathematics where multiple number of variables are involved. For example, x, y and z, or n number of multiples are involved. So basically, I would like to talk more about the applications part of this mathematical phenomenon, and for basically I'll just start with a brief introduction and a technical part. So let me take a function f(xy) equal to something, and let me differentiate it once with respect to x, partial differentiate with respect to x, fx. Also I can take a partial differentiation of this same function with respect to y, fy. And also there's one more concept I'd like to explain. It's called differentiation with x and y. So basically what this is, first I will differentiate this function with respect to x, and then this function f of x I can differentiate again with respect to y. So that will also equal to something. F double x. This is the differentiation of x again with x with respect to x. So it's called double differentiation of x, f of x. And similarly f of y, double y, is the same thing, differentiation of this term with respect to y again. I'd like to introduce a new concept called discriminant. I'd like to introduce a new topic called as discriminant. I'd like to represent it as D. So basically what discriminant is, it is the product of f double y, f double x, and I'll subtract the square of f xy. This is what we call as a discriminant. So basically from this solution I can come to three possible conclusions. First of all, the discriminant can be equal to 0, discriminant can be greater than 0, and discriminant can be less than 0. So if I get my discriminant equal to 0, then I can come to the conclusion that the discriminant has no possible conclusion. So I'll just write no conclusion possible. If my discriminant is greater than 0, then I can conclude that a possible solution exists. And if my discriminant is less than 0, then I can conclude that it is a saddle point. So basically using this phenomenon, I can calculate my critical points, I can use it to find maxima and minima, and various other things are possible. For example, if t greater than 0, I get solution exists, and my f of xx is greater than 0, then I can come to that conclusion at that point it's a minimum point. Then I can substitute it in this function and I can get the minimum value of that function at that point. Alright, let me come to the main part, the application of multivariable calculus. So basically, multivariable calculus will be used in any branch of mathematics, physics, robotics, computer science, mechanics, anywhere where I have multivariable numbers. For example, x, y, z, or n number of variables I have. I can use this phenomenon to help me calculate various things. So first let me come to part of mechanics. Multivariable calculus is extensively used in mechanics where I can use it to find linear relationships between speed, position, as well as acceleration. Also mechanics also utilizes mechanical stress, which also utilizes a lot of multivariable calculus, considering the fact that mechanical stress makes use of almost up to 7 variables. So multivariable calculus is very important in the field of mechanics. Also mechanics, I can talk about aerodynamics, which utilizes multivariable calculus in designing various aeroplanes and helicopters and all that stuff. Right. So let me come to computers. We utilize multivariable calculus a lot in computers regarding high-level algorithms. And we can also use it in computers in virtual reality to stimulate real-life scenarios. So, also as I talked about virtual reality and artificial intelligence, multivariable calculus will definitely be used in robotics. It's used in programming for robotics, so multivariable calculus will be used in giving the program information about multiple things such as position, the location, and speed and acceleration and all that stuff. So I'll just write programming. Okay. Multivariable calculus has also applications in various branches of physics, which is very important. It's basically mostly used in electrodynamics and magnetism, because we know that electrodynamics will make use of electric fields, and for that we need to know the position and the point at which we are going to find the electric force or magnetic force and all that stuff. So basically you might be given electric field at a point in x and y direction vector. You need to find the electric field at a point z. This is a two variable concept. We need to implicate it in a point on a z axis. So for that we need multivariable calculus. Distribution physics also. So this is basically all the applications. I couldn't talk much about it, but it's a vast topic, and I like to conclude my presentation, and I hope you liked it. Thank you.